Hey everybody, Mr. Klein with you. We are in a unit where we're going to be talking about studies, and in any study you're going to have variables, and the goal of any study is the same. We want to establish the relationship between two or more variables in that study. That seems abstract. Let me give you a quick example. Here is a study on HIV. And people that have HIV, they were given a treatment, either something called NRTI, or they were given a placebo. And then we looked at their viral load after a certain number of weeks, how much virus they had per millimeter of blood. And the goal of this study was to establish whether there is a relationship between the treatment that the subjects received, the NRTI or the placebo, and their viral load, right? So two variables looking at the relationship. Here's another quick one. This one was about zinc. People who had colds were given either zinc or they were given a placebo. And then it looked at another variable, whether or not their symptoms of the cold resolved. Okay, so again, we've got two variables. We're trying to establish a relationship. Now, there are two types of relationships that we might encounter. There's something called association. And when we say, I don't know where that's coming from, I don't have a dog. When we say that there's an association, all that means is that the two variables change together. Okay. When one increases, the other increases, or when one increases, the other decreases. Could be either way. Let's contrast this with something called causation. Causation is when changes in one variable lead to changes in the other. A quick example of how these are different from each other. Think about what happens as you age. You get taller, and as you age, you get better at math, right? You know more math. So we would never suggest that getting taller causes someone to be better at math, but we could say that they are associated. As your height increases, your math ability also increases. We use symbols to talk about these. When I talk about two things that are associated, I'm going to use a little dashed curvy line like that. And when I want to suggest that one variable causes another variable, I'm going to draw a solid line with an arrow running from the variable that causes to the variable that receives the effect. With that in mind, when you have two variables and they are associated, changes in one move along with changes in the other, there's really three different things that can be going on. So I'm going to give you three examples of studies. For the first one, we've got a bunch of single adults. That are all 30 plus, so they're out of school if they went to school. And in this study, they were asked for the number of hours that they sleep. We studied sleep in our last unit, right? And that's measured in hours. And not that it's a big deal, but I'm going to just write a Q here to note that that's a quantitative variable that we're measuring. And then they were also asked the amount of money that they have in their bank account, which money is measured in dollars. So that's also a quantitative variable. And it turns out that these two things, strangely enough, are associated with each other. And it is a negative association. A negative association means that increases in the average hours of sleep that a person is getting are associated with decreases in the amount of money that they have in their bank account. Now, when we have an association, we have to think about causation. Is it possible that one of these variables is causing the changes in the other? Well, would it make sense that just by getting a couple hours of sleep tonight, your bank account drains of money? No, that is ridiculous, right? So there is no causal relationship here. There is no possible causation. And when there is no possible causation, but we have an association between two variables, we look for a third variable that could explain the association. In this case, there is a variable. Can you guess what it is? It's employment. If a person is employed, that person tends to spend a lot of time at work and sleep less. If a person is unemployed, that person spends more time at home, has more time to sleep, and sleeps more. Okay, so employment has a causal relationship on sleep. Employment also obviously has a causal relationship on dollars, because if a person has a job, then they got more money in their bank account. If a person has no job, they probably have less in their bank account. Okay, so no causal relationship here at all. There's this third lurking variable that explains them. If you run into a situation like that, we have a name for it. We call it a common response. Okay, both of these variables have a common response to the employment variable. So there's our first type of association. Here's our second one. Okay. This time we have people with a variety of ages. Not sure whether that's important or not, but I just figured I'd let you know. And this time we have a study where we go out and we ask them how many hours a week they sleep. Okay, once again, measured in hours. And then we measure their blood pressure. Blood pressure is measured in millimeters of mercury. You know, like the first instruments that were used to measure blood pressure used mercury, and they, you know, like press that thing into your bicep. And so that's the way that it's measured. Now, this one also has a negative association, meaning that as people sleep more, their blood pressure on average tends to be lower. Now, here's a good example of how a negative association doesn't necessarily mean a negative thing, right? It's good to have low blood pressure. In this case, the negative just means that as this one goes up, this one is going down. Now, in this case, is it plausible that getting more sleep could cause someone to have lower blood pressure? Absolutely. So there's the possibility that this causes this. However, think of all the other factors that also could be causing this, right? There's diet. A person's diet could lead to lower or higher blood pressure. Also, there's the amount of stress that a person has in their life. Higher stress will lead to higher blood pressure. Lower stress will lead to lower blood pressure. So while it is possible that these people that we went up and we asked them how many hours they sleep a night, and then we measured their blood pressure, it is possible that the sleep is causing the lowering blood pressure, but we can't separate the sleep from these other factors that could also be causing the lower blood pressure. And so we call this confounding. Confounding means that we can't separate the effects of sleep from the effects of diet and stress. Are you with me? Now, the question is, what if we actually wanted to be able to show that this causes this? What would we have to do? Well, here's my hint. This study that we just looked at, it was an observational study. Observational study means that we just observe the behavior of people and we don't actually try to impact their behavior. If we did try to impact their behavior, we wouldn't be doing an observational study anymore. We would be doing something else that's very important in science, and that is an experiment. So imagine that we do an experiment. And once again, it is on people that are a variety of ages. And in this experiment, what we're going to do is we are going to control the amount of sleep that they get. We're actually going to assign it. We're going to have them sleep in a lab each night where we can control their sleep. And one group is going to get 4 hours. One group is going to get 6 hours. And another group is going to get 8 hours. These 3 different levels of sleep that I just described, they have a name. They're called the treatments. Okay. Now, all those other variables like diet and stress, we're going to control those. So we're going to control diet and stress by feeding everybody the same kind of food. So everyone's consuming the same diet and putting them in the same environment where they will be dealing with the same kinds of stresses. We won't make anyone work, that sort of thing. All right. So the only thing that is changing in their lives is the amount of sleep they're getting. Now, if this time we find that still their blood pressure has a negative association, meaning that as the number of hours of sleep increases, the blood pressure is going to go down, then we can say sleep causes lower blood pressure. And we would refer to this as true causation. So in conclusion, I'm coming back to my first page here. There are 2 types of studies that we are going to work with in this class and that exist in the world. The first is called an observational study, and that's where we observe behavior, but we do not interfere. With our subjects. We just ask them how they behave. The other kind of study that we're going to look at is an experiment, and this is where we actually impose treatments. On our subjects. Now, why is the difference between these important? Because of this. And if you get one thing out of today's lesson, I want it to be this one. In an observational study, we can only show association. We can only show that changes in one variable are associated with changes in another variable. They move together. Whereas with an experiment, we can show causation, that one variable causes the other. The